Okay, section 7.3 is proving triangles similar. So we're still working with similar polygons. So to postulate 7.1 is the angle-angle similarity. It can also be written just by AA and then the similarity symbol. And it says if two angles of one triangle are congruent to two angles of another triangle, then the triangles are similar. So if I have two triangles, we'll call one A, B, C, and I have another triangle, D, E, F. If I have two angles, one in each triangle that are congruent, in other words, if angle A is congruent to angle D and angle B is congruent to angle E, then we can say that triangle ABC is similar to triangle DEF. So two angles, angle-angle, are enough to prove similarity. We'll do a problem with this in a minute. So here's another theorem. This one's a theorem, 7.1, side-angle-side similarity theorem, or side-angle-side with the similarity symbol. If an angle of one triangle is congruent to an angle of a second triangle, so this time I only need one angle, and the sides that include the two angles, we'll talk about what that means in a second, if the sides that include the two angles are proportional, then the triangles are similar. So if I have a triangle that looks like this, and another one that looks like this, A, B, C, D, E, F. And if I have at least one angle that's congruent, so we'll say angle A is congruent to angle D, and the sides that include the angles, so the sides that form the angle, so in this case AB and AC, on this triangle DE and DF. So if AB, when set in a ratio to DE, because those are our similar sides, AB and DE, and if they are proportional to or equal to AC over DF, in other words, if side AB side AB over DE is proportional to AC over DF, then triangle ABC is similar to triangle DEF. Okay? And one more way of proving similarity is theorem one more theorem, sorry. Theorem 7.2 is the side-side-side similarity. If the corresponding sides of two triangles are proportional, then the triangles are similar. So again, if I have two different triangles, A, B, C, D, E, F, if the corresponding sides, so if AB over DE is proportional to BC over EF, which is also proportional to AC over DF, if all three sides, corresponding sides, are in a proportion, then again triangle ABC is similar to triangle DEF. So let's try one or two of these. I think we're just going to do one because this is pretty similar to what we did last night or yesterday. So let's say I have this triangle, and I'm going to put a triangle inside of it. So I'm going to call this K, L, P. I'm going to call this M and this N, and I want to prove that triangle KLP is similar to triangle KMN. So the inside triangle, KLP, and we want to prove that similar to KMN. So I either need several angles, two angles, or I need an angle and the inclusive sides, or I need all three sides. Well, I'm going to give you a couple side lengths. KL is 8, LM is 2, KP is 12, and PN is 3. I also know something about the angles here. Since I don't have these two sides, I don't know what they are. Okay, I can't use side, side, side. But I do know something about the angles. Do you know anything about congruency of the angles here? Well, angle K is in both triangles. So angle K is congruent to angle K. Do you remember the property for that? Reflexive property. It's congruent to itself. And then I can say that KL over KM, those are the corresponding sides here, is proportional to KP over KN. And if that's true, I can prove the similarity. So KL is 8, KM is 10, adding up the 8 and the 2, KP is 12, KN is 15. Got to add them up. And is that proportional? Well, we can use cross product, or we could just simplify both of these. 4/5 does equal 4/5. Therefore, triangle KLP is similar to triangle KMN. Okay, so we will do a few more of these in class, and that's it.